Now let's re-implement the interpreter of FAE. We have been implementing FAE interpreter for several weeks, right? For a given expression under a given environment, how to evaluate that expression to produce a value. And this time we are going to implement interpreter in a continuation passing style, which takes work to do as the last parameter. What does that mean? Let's see. Interpreter takes an expression, an environment, and work to do. It's a function. It takes a value and produces a value. Then, for a number case, how do we interpret this? Number is a number. So for a num expression, we used to produce num-v value. Num-n is an expression, num-vn is a value. And it used to be that's it. But this time, we need to use continuation. What's the meaning again? Under this environment, when we interpret this expression, we are going to get a value. Then, using the value, do k. K is the remaining work to do using the value of this expression. Meaning that under this environment, when we interpret an expression, we get a value. Using this value, we are supposed to call k, because calling k is the work to do. So it's going to be like that. In this continuation passing style, when we have a value, we need to call k. And then we don't need to come back. It's going to be a bit more clear and slightly more complex when we have expressions that are not constructing values. Until then, easy cases come. So identifier, when we interpret an identifier, how did we do that? What's the value of an identifier x? Remember, what did we do? Yeah, that's why we have an environment. Well, if you want to know the value of an identifier, look up the environment and get the value. That's the usual thing. Look up the environment using the name. If the name has a value in the environment, get it. Otherwise, throw an error. Free identifier error. That's the usual thing. But this time in continuation passing style, when we have a value, what do you expect to do? Using the value, what are we supposed to do? Yeah, call k. Again, using that value of the identifier, call k. Because what to do next is going to be described by k. What you are supposed to do with the name, the value of the name, that's all captured in this k. Oh, it's a magic, right? When do we create that k? Wait a bit more. Okay, again, function expression. When we have a parameter and a body expression, what did we do? Yeah, we made a closure V by using this parameter name, body expression, and an environment. But this time, what are we supposed to do? Call k. Call k using that closure V value. So far, so good, yeah? Because until now, these are easy cases. If you remember, we have numbers, addition, subtraction, identifier, and function expression, and function call, right? This number, identifier, function expression, they are all what? Value creating expressions. Not really creating, value producing expressions. It does not have any sub-expressions to look at. But addition, subtraction, and function call, they all have two sub-expressions. Then how can we make continuations? Remember in the beginning we talked about E1 plus E2 and what is a redox and what is a continuation, right? E1 was the first redox. The remaining work to do using the value of E1 is continuation. We are going to represent that in Scala. When a given expression is an addition of L and R under this environment and a continuation, what are we supposed to do? You know, it's an addition, so as usual, we are gonna interpret the first sub-expression under the given environment, the second sub-expression using the same environment. But what's this last argument? This interfunction takes an expression, an environment, and what is it? That's gonna be the work to do. Oh, what is that? That's gonna be the work to do using the value of L. One more time, in this continuation passing style, interrupt takes an expression, an environment, and a continuation. And the meaning is that under this environment, evaluate this expression, get the value V, using the V, call K, right? Okay, then what do you mean? Interpret this L under this environment. When you have value LV for this L, call K, right? So we need to make a K. We need to make a continuation for this one. Cont again is what? Takes a value, produces a value. Okay, then what's gonna be this function expression? It's gonna get LV and do some work, right? So interpret L under this environment, and when you are done evaluating this L, get the value, call it LV, and do this work. Does it make sense, right? One more time. When we have an addition expression, the first thing to do is to interpret L. That's the redox. And the remaining work is that's a continuation. This is the third time that I'm telling you. An expression is either value or not. When it's a value, then we are done. Just, num V, closure V, we are done. We do not need to evaluate further. If it's not a value, then we need to evaluate E1 plus E2, E1 minus E2, E1 with the argument E2 like that, right? E1 semicolon E2, They all have an expression to evaluate the first redox and the work to do with the value of the first redox, value of the redox, right? So here, this is redox, this is continuation. Then, when you know the value of L, what are you supposed to do next? Evaluate E2, right? Yeah. Interpret R under the given environment. Then what is this K? Oh, when you have a value of R, what are you supposed to do? You think about it. When you have a value of R, what are you supposed to do? Get it. Get RV. And do some work. That's going to be the continuation. Are you with me? Yeah? So, when you interpret the second sub-expression under the given environment, then the work to do next is what? Work to do next is get the value of R and then do the remaining work. What is the remaining work? Add two values LV and RV and get the result, addition, right? Okay, then using that LV plus RV, what are we going to do next? Is it done? Are we done? Is there anything to do more? Hmm? Yes. We haven't done k yet. Using this value, we need to call k. Ooh. So far so good. Let me review one more time. Let me review one more time in English and then Korean. When we have an expression to evaluate under a given environment, then we are going to evaluate this expression under this environment, and then we're going to have a value, right? Value of E. Then using the value of E, what to do next is call K, right? Meaning K using the value. When we have an addition expression, how are we going to interpret that? Interpret the reduce, the first of expression under the environment, and represent the remaining work as a continuation. What's the continuation? When you are done evaluating L, you're going to have value V, right? LV. Then you need to call this function. Yeah, this continuation. So what? Yeah, get that value LV for this L, and you're gonna evaluate the second sub expression R under the same environment and make another continuation. What's the continuation? When you're done evaluating R, get the value, and finally you have two values LV and RV, so do that operation, addition, and finally call K. Are you with me? So subtraction is no different. So let me explain this in Korean because it's just the same. Continuation passing style이라는 거는 인터프리터가 어떤 environment에서 이 expression을 계산하는데 K를 쓰라는 거예요. 다시 말하면 이 환경에서 얘를 막 계산하고 나면 value B가 나올 텐데 그 B를 가지고 할 일은 이거예요. K를 불러요. 그 value를 아규멘트로 해서. 이거예요. 그러니까 인터프리터 계산할 때 세 번째 K 컨티뉴에이션을 한 땀 한 땀 만들어줘야 돼요. 어떻게? subtraction이에요. 그러면 얘는 먼저 첫 번째 sub expression을 주어진 환경에서 계산을 해서 값이 나올 거예요. 그 값을 가지고 할 일은 이거지요. 이거겠지? 이거예요. 그게 뭔데? 그 값 LV를 가지고 다음 할 일이야. 첫 번째 서브 익스프레션 다 계산하고 나면 할 일이 뭔데? 두 번째를 계산하는 거지. 그래서 똑같은 환경에서 R을 계산하고 그 다음 할 일도 컨티뉴에이션으로 만들어 인 거죠. 그 다음 할 일은 또 뭔데? 뭐죠? 두 번째 서브 익스프레션 계산해서 값 받았잖아. 그럼 이제 둘 다 값을 안 해. 더해. 아니지. 빼. 빼요. 빼고 나서 나온 값을 그냥 리턴하면 틀리겠죠. 왜? 콜 K 했잖아요. 그래서 K를 불러야 돼요. Okay? So, whenever you are not sure, then call K. Okay? Whenever I ask you, what's missing or what are we gonna do next? Call K. If you start using continuation passing style, you need to go with continuation passing style till the end. If you do not pass K here, it's gonna be an error. It's not gonna work at all. Once you chose to use CPS, continuation passing style, then you need to do that from top to bottom. Okay. Function application, yes, as you expected, as usual, function application is the key. But it's not that different or not that difficult because now you've seen addition and subtraction, yeah? Application, function call is yet another expression with two sub-expressions. When you have two sub-expressions, what do? You interpret the first sub-expression, you interpret the second sub-expression. Right, just like addition and subtraction. Let's implement the first sub-expression first, because that's the redux. Then interpret the first sub-expression under a given environment. Yeah, what's the K then? Now you should be able to guess because we already saw how to do addition and subtraction. So interpreting a function call is to interpret the first expression under this environment, get a value, and call this K. Call this continuation. What is that continuation? That continuation should get the value of this function part. And using the value, it should interpret the argument expression and go on. So, just like that, just like with addition and subtraction, interpreter evaluate the first sub-expression under the given environment and get the value. Using the value, it interprets the second sub-expression under the same environment and call this K. What is this K? When you have function value and argument value, what did you do? Function call when you have function value, argument value. When you have function value and argument value, what did you do? Yeah, there are how many kinds of values in this FAE? 2, right? Num-V and closure V. So we need to check as usual whether this function value is closure V or not, and then go on, right? That's gonna be this continuation. We can check when you are done evaluating F, call it FV. When you're done evaluating argument expression, call it value AV. And what are you gonna do? Check whether that function value is closure V or not. If it's not closure V, it's num-V, so throw an error. If it's closure V, it has its parameter name, body expression, and the environment when this closure V was constructed. Oh, yeah. Familiar? Yeah? Then, finally, what are we supposed to do? We are supposed to interpret the function body. Yes, the function body. We are supposed to interpret the function body on top of what? A new environment. What is that new environment? On top of this environment captured in closure V, we should have the information that the parameter's value is AV, right? Yeah. So interpret the function body under this environment. Which environment? On top of the environment when the closure V was constructed. Extend that with the parameter, yeah, has this argument value, right? Okay, so far so good, because it's just the same as before. We are going to interpret the body expression under this environment, and what's the next thing to do? What's the next thing to do? Yeah, the whole question in continuation passing style is, what is K? In continuation passing style, because under a given environment and for a given expression, that's all we had to have in the previous version. But now that it's continuation passing style, we need to pass continuation. That's why whenever we call this interfunction, we have these obvious expressions and obvious environments, and then we have to make our own continuations, right? Do you see that? This is matching parentheses, I don't know, yeah. This is first continuation. This is second continuation. And this is the third continuation. We are making continuation. Continuation again. Value, arrow, value, function. Right? This is a lambda function. Value, arrow, producing a value. Value, arrow, producing a value. So what is it? Okay? when we are done evaluating the first sub-expression, we interpret the second sub-expression. When we are done evaluating the second sub-expression, we evaluate the function body. When we are done evaluating the function body, what are we gonna do next? That means when we are done evaluating function call, what are we gonna do next? Do you see that? Call K. Right? Yes. So that's gonna be the thing. We are gonna call K. Do you see that? So let me repeat or summarize how to implement this interpreter for function call in English and then in Korean. Multiple times, right? Yeah. Hopefully you get it now. Interpreting an expression which is a function call requires an environment and a continuation. So as usual, we are gonna interpret the first of expression first because that's the redux. And then when we are done evaluating this function part, we are gonna call this continuation using its value. So we need to express that as a lambda expression. What are we gonna do with the value of function expression? Keep it, okay? Keep it in the environment and evaluate this argument expression under the given environment. And when you are done there, what are you gonna do? We are gonna call this K using argument expression value. Now that we have argument expression value, what are we gonna do? Because we have FV and AV, we can finally check whether function value is closure V or not. Actually, checking come first, but we can discuss that later when we need to. So then if it's closure V, otherwise throw an error. If it's closure V, we are going to interpret body expression under the usual environment. Then when we are done evaluating function body using the value, what are we gonna get? What are we gonna do? Call K. Why? That's the continuation that we are supposed to do after evaluating function call. Okay, let me briefly repeat this in Korean. 여러 번 했으니까 이제 빨리 얘기할게요. 펑션 콜일 때 어떻게 한다고요? 펑션 콜이고 자시고 서브 익스프레션이 두 개니까 첫 번째 거 먼저 계산해. 그죠? 그러고 나서 뭐해? 그러고 나서 할 일이 컨티뉴에이션이에요. 그거를 한 땀 한 땀 우리가 람다로 열심히 만들어야 돼요. 너 이거 계산해서 값이 나왔지? 그럼 FB라고 부르자. 그리고 람다. 그 다음에 할 일이 뭐야? 인 거죠. 두 번째 익스프레션을 계산해야지. 오케이. 인트럽 두 번째 익스프레션 그거 다 계산하고 뭐 할 거야? 또 이 람다를 만들었지. 그게 뭔데? 두 번째 익스프레션의 값을 받아서 함수 콜을 하는 거죠. 함수 콜은 뭔데? 요 첫 번째 익스프레션의 값이 클로저 B가 아니면 망한 거고 에러. 클로저 B네? 그럼 바디를 계산하자. interpret body 그리고 요 맨날 하던 그 environment에서 하는데 바디 다 계산하고 나면 그 값으로 뭐 하지? 뭐 하죠? 소고기 사 먹나? 아니죠. 그거 가지고 K를 불러야 돼요. 왜냐면 이 K가 펑션 콜 하고 나서 요 익스프레션 계산하고 나서 할 일이라고 했으니까. 됐죠? Now let's take the second break. This is 갑천. This picture my friend, one of my colleagues took and he thought it was so beautiful, meaning that Daejeon is so nice, right? Let's take the second break and come back to the last part of today's lecture.